All right, it's space weather! Looking at the NASA SDO data in 171 angstroms, we're seeing some highly anomalous data here. That's not the way it usually looks, is it? So, okay, what's going on with that? Not sure there. Pretty sure that data is anomalous. Let's see if it shows it on all the wavelengths. Sure enough, it does. We're hoping the magnetic field force lines of the sun aren't actually looking like that, and we're assuming that they're not. So we're not going to get too into the weeds on that one. Looking at the sun in 304 angstroms. Lots of filamentary activity, no sunspots. There is an apparent small equatorial incoming coronal hole. And if you didn't see yesterday, interesting filamentary activity up here. Check out this one as it destabilizes. There it goes. Boom. Right. So we're going to take a quick moment today to not get too deep down the rabbit hole, but we're going to talk about cosmic rays a little bit after we cover the regular stuff, and we're going to leave all the links to all this stuff below. For now, let's go to spaceweather.com. X-ray flux, still very flatlined in the A range. Solar wind. Well, it's got some anomalous data there on the ACE also. Interesting. But solar wind, the density is still below 10. The phi angle looked like it wanted to go to 180 there. So, not so sure what's going on with that. Solar wind density and speed, they're all pretty flat. Now, we saw that crazy anomalous data from the SDO image. No kind of anomalies on the GOES magnetometer. And the KP index is at 2. Electron flux is looking pretty anomalous. It's kind of all over the place. And there's your F2 ionosphere layer. It's a little on the charged side. With a KP of 2, I mean, it's probably going to come down. This is probably going to discharge throughout the day. Now, for those of you who are not aware of the relationship between solar activity and cosmic ray flux, here's a great little graph here. Solar activity is inversely proportional to cosmic ray flux as far as we can tell. As you can see, cycle 24 is the weakest cycle that we've had, and these cycles are calculated by counting sunspots. As you can see on the graph here, we've got the highest level of cosmic rays that we've ever measured. Again, we will leave links to all this, and there are sites that monitor this stuff constantly, like this one here. All real-time data from all around the world. Kuwait, Russia, as well as the US. And again, we're not going to get too deep into the weeds here, but our favorite cosmic ray source is Cygnus X-3. For those of you who are not aware of what this is, it's in the constellation Cygnus. It's the tail of the swan, the star Deneb, one of the largest and brightest stars that are visible in the sky, which is a Wolf-Rayet star being orbited by some really massive radio source where one of the relativistic jets is pointed straight at the Earth. During the precession of the equinoxes, this particular star actually becomes our North Pole. So anyway, just wanted to do a little piece on cosmic ray flux. Again, we're going to put all the links that we've shown here in the description below. Thanks for watching. Stay tuned. There is a coronal hole on the way in. Actually, let's take a look at that real quick. Go back to the SDO. This gives you a pretty good view of it. Just rising over the eastern limb. Actually, it's just appearing as it rises. Right about here. There it is, rotating in. Otherwise, not a lot of news, which is why we covered cosmic ray flux today. More to come. We're going to do a video completely about Cygnus X-3. It is all in the works. Thanks for viewing. Please like, subscribe, share the videos. Visit us on minds.com/smashomash, facebook.com/smashomash, and don't accept any wooden nickels.